Most people are afraid of IPv6, and I don't blame them at first. We have a larger address space. It's 128 bits versus the 32-bit addresses that we have with IPv4. But not only that, we're dealing with hexadecimal characters now, numbers and letters, versus just numbers with IPv4. IPv4 was hard enough. And we can all admit that's pretty tough. But IPv6, it's even harder. But it's the addressing of the future. And we have to learn to love IPv6. So what's one of the ways that we can deploy IPv6? We can deploy it statically. Now, we're not going to do that to the end stations in our environment. That's going to be an absolute nightmare. However, router interfaces will deploy static IPv6 addresses to the router interfaces. And what is the biggest issue you're going to run into when you deploy static addresses to the router interfaces? Well, the biggest issue is you. That's right, I said you. The administrator typing in an IPv6 address incorrectly. It happens, we're humans, we make mistakes. No big deal. But it's up to you to fix that problem. So if you recognize by going to the show IPv6 interface output for that particular interface and you realize the address is incorrect, what should you do? Remove the incorrect address. That's right, remove it. That's completely different than IPv4. What did we say with IPv4? We said simply type in the new address. And when you type in the new address, what occurs? It simply overwrites the old address. Well, that's not what happens with IPv6 because you can have multiple IPv6 addresses on a router interface. So you want to remove the old addresses that you don't intend to have on those router interfaces. And then apply the correct IPv6 addresses that you want on the interface. Now, how much of the IPv6 address can you make a mistake on? It's not a trick question. You can make a mistake on all of it. You can type every single character incorrectly. Probably not going to happen. But all it's going to take is one of those characters to be incorrect when you type it in, and then your addressing is not accurate. So how can we reduce the likelihood of making a mistake? We can rely on EUI64. What EUI64 gives us the ability to do is configure just the first 64 characters of the IPv6 address. So essentially, the network portion, the prefix. And then from there, using EUI64, the router interface can derive its interface portion, so the latter 64 bits of that IPv6 address. And how does it do that? Well, it uses its 48-bit MAC address. Wait a second. 48-bit MAC address equals a 64-bit interface IPv6 portion. That doesn't make sense. So how does it accomplish this? How does it come up with the necessary fluff to turn that 48-bit MAC address into a 64-bit IPv6 interface identifier? Well, what it does is it takes the MAC address. So we'll have our first 24 bits of the MAC address and our latter 24 bits of the MAC address. So it simply splits the MAC address in half, and then in between it fills it in with fluff. Why do I say fluff? Well, somebody once told me FFFE, which are the hexadecimal values that are put in between, they remember it by saying fill the field with fluff every time. That's right. Fill the field with fluff every time. So we have we now have a total of 64 bits representing the interface portion of that IPv6 address using EUI64. So let's go out to our router here. And our router we want to take a look at is DSW1 in this case. So we'll grab DSW1 and let's take a look at the IPv6 interface. Show IPv6 interface VLAN 10. So VLAN 10, even though it's an SVI, it can still have an IPv6 address. And right now it has this statically assigned IPv6 address. Global unicast IPv6 address. 2001 DB8:1. we look at the output of show run interface VLAN 10, we can see from this output right here that I typed in the whole address. EUI64 is not being utilized because if it was being utilized, it would say so there as well as up here. So let me show you what that looks like. Configure terminal, interface VLAN 10, IPv6 address. We'll say 2001:DB8 /64 and then EUI64. So the first 64 bits are going to be 2001:DB8:0:0, and then after that, it's going to automatically generate the latter 64 bits based on the MAC address of the interface plus FFFE, fill the field with fluff every time. So if we look at the output of show IPv6 interface VLAN 10, we'll see now we have 2 IPv6 addresses assigned because we can have more than one, and it was done via EUI64. There, this is the prefix, but look what it did right there. That's what I'm interested in. 2A93FEFFFE3AE345. There's your FFFE. It just so happens that the MAC address has an F and an E in it before the FFFE, which might throw you off in this particular case, but no, the fill the field with fluff every time is right there. There's the lower 6 hexadecimal values of the MAC address, and there's the upper, oops, missed it again. There you go. There's the upper 6 hexadecimal values of the MAC address. So let's examine this value right here and compare it to the MAC address of that interface. So we're going to type in show interface VLAN 10 pipe to include BIA. All right, so here's the MAC address, 2893FE3AE345, and if we go all the way up here, we can see they don't match. They don't match. Why? Well, I see a 2A here, and I see a 28 here. Everything else matches with the addition of FFFE in between. So it's thrown in between the E and the 3 here. But what about this 28 versus the 2A? Well, just to make sure that the address is unique, it does a bit flip. That's right, it does a bit flip. Let me explain to you this particular EUI64 bit flip that is going on. So this 2A we see right here, let me grab a different color. There we go. This 2A that we see here versus this 28. Well, let's take the 28. So we have 2 and 8, and break that up now into binary. What is 2 in binary? It's 0, 0, 1, 0. What is 8 in binary? It is 1, 0, 0, 0. Well, with FFFE, the standard says take the 7th bit from the left and flip it. So the 7th bit from the left is going to be 0, 0, 1, 0, 1, 0. Here's the 7th bit right there, 0. So now we can convert these back. This is 2 in hexadecimal, and this is 10 in hexadecimal, which equals A. So there's our 2, and there is our A, right there. So 2A, 93, FE, fill the field with fluff every time, and in the bottom portion of the MAC address. So we were able to come up with a global unicast IPv6 address in this case that is unique by simply using the MAC address associated with that particular router interface. Less chance of error in this case when we're trying to come up with unique identifiers for the devices within the network.